Hello, quick video on straight lines and gradients and equations of straight lines for A level, and also looking at parallel and perpendicular lines. So quite often we're given the relationship between two variables and we need to find out the equation of the line and then look at parallel and perpendiculars. So if this was a line here, then we've got our parallel line, or we can have a perpendicular one which is at right angles. In order to find those, we need to use gradients. Okay, let's start by having a generalized form of a straight line. You may well at GCSE have been taught y equals mx plus c. I'd recommend not using that, but to use this other format at A level, and I'll explain why. Okay, so if I've got a straight line starting at this point here, x naught, y naught, and I know that for every one I go along, I'm going to go up m, then that's going to be my little gradient triangle. Then I also know that for any other point that I go to, x and y, up here, that we've got a similar triangle, haven't we? So if I'm looking at this in this generalized form, this base, if I go, is going to be x minus x naught, and the height here, it's the up it's going is y minus y naught. Yeah, we okay with that? So therefore, if I look at the ratios of these sides, then y minus y naught over x minus x naught must always equal m over 1. If I reorganize that by multiplying by the denominator, I get this equation down here. So if I take my distance that I've gone, my change in x, multiply it by m, my gradient, I'm going to get my change in y. And that's a fairly simple thing to do, isn't it? Okay, so let me give you the example of that. If I start at the point 4, 3, and I've got a gradient triangle, so every one I go along, I go up 2, then m equals 2, doesn't it? So my m's therefore going to be 2 to put into this equation. And then I know that I'm going away from the point 4, 3. So on my x side of my, the base of my triangle is going to be x minus 4. And the vertical side of my triangle is going to be y minus 3. So that's a very simple way of constructing the equation. I can then simplify it and play around with the numbers, but that's the quickest way of constructing it. Okay, what's a parallel line then? Well, two parallel lines don't meet, do they? Yeah, and the only reason that they won't meet, the only circumstance that will be is if they've got the same gradient here. Otherwise, they're going to bump into each other at some point or other. The difference is that they start at different points. They go through a different point, yeah? So if I use the example we had earlier, we had our m was equal to 2, so that's our m equals 2 here. Then we know that all parallel lines must have m equals 2. And of course, all we have to do with our little triangles that I talked about earlier is to fill the values into the triangle. So if I have a new parallel line that starts at the point 6, 5, then my base triangle is x minus 6, and my height of the triangle is y minus 5. And there we go again. Very quickly, we've got a form of a parallel line. Okay, what about a perpendicular line? Well, if our baseline here that we're working off is this red one, and we know that our gradient triangle, therefore, if I draw it in, is therefore going to be 1 and m. If I want a line that's perpendicular, that is at right angles, you can see that what I've actually done here is rotate my gradient triangle 90 degrees clockwise. So you can see quickly these are similar triangles because that angle there is going to be the same as that angle there, isn't it? Just because we've got a 90 degrees in this corner here. Okay, so our 1m triangle, now the 1's on the vertical and the m's on the horizontal. Yeah, so can we see quickly that our up over along here, which gives us our gradient, our up over along, well, our up is actually minus 1, isn't it, on this, and our long is m. There we go. So we've come up with a generalized expression here and formula, that the gradient of a perpendicular line is going to be -1 over m of the original line, and we can use that throughout. Okay, so let's have a look then, and using the example we had earlier, it went through the point 43 and our baseline had a gradient of 2, so there's our gradient triangle there. If we rotate that triangle round, we can see that we've got our gradient is -0.5, and if we use our generalized formula here on the left hand side, then our gradient of our perpendicular is -1 over m, the gradient of our original line, and m was 2, so again we get -0.5, don't we? And we can immediately drop that into this generalized form that I'm using here at the bottom. So our gradient is now -1 over 1/2, and then we're just going to find our two brackets. So the base of any triangle that we're building on our new line is x -4, and the vertical on our triangle that we're going to be creating is y -3, and therefore again we've got a very simple form of the equation very quickly. Okay, so let's have a look at our generalized form of this. There's the general form I'm recommending, and of course this is all based on this little gradient triangle, that if this point is x, y, and that point is x0, y0, then the difference is always going to be in the ratio of m. Yeah, the difference is the side lengths, yeah, and always going to be in the ratio m. If we want a parallel line, it's going to have the same value m, and we've got the same got a new triangle here, so we've got different start points, x1, y1. And if we want a perpendicular line, we have to remember that the perpendicular gradient will always be -1 over m. From the similar triangles approach, we took that triangle in, we rotated it 90 degrees clockwise, and again we've just got our two brackets here for the base and side of our triangle. So there we are. I hope that's of use.